Hello, fifth graders, it's Mrs. Tremblay, and we are starting Unit 5. And in this unit, we are going to still multiply and divide like we did in Unit 4, but we're going to incorporate some decimals into the mix. And there are some other multiplying by powers of 10 and dividing by powers of 10, but with decimals. And that's what we're going to look at today, as a matter of fact. So you should have your your Unit 5 packet, and there's a copy attached if you need it. We're just going to look at Lesson 1. That's just the front page of this. So if you are printing from home, you only need the first page. And after this, we will do a little bit on our whiteboard. So if you want to grab those materials now or some scrap paper, you're good to go. All right. So we're going to start off. We're going to look at multiplication with powers of 10. And just a refresher of what we did before. You basically learn when you multiply by a power of 10, when you multiply by 10, that means that all of these digits are going to shift over to the left, and we end up having to put a 0 as a placeholder, right? So we learned that to do 32 times 10, you could just multiply 32 times 1, which is 32, and put a 0 after that, right? Because all the digits shift over. Okay, same thing, 85 times 100. 85 times 1 is 85. And then 100 is like having 10 twice, right? 10 times 10 is 100, so 2 zeros, 2 zeros. And 27 times 1,000, I can do 27 times 1. And then this is like having 10 3 times, right? 1,000 is 10 times 10 times 10. So that would mean 3 zeros, right? Well, down here, you're going to see this looks a little bit different. These numbers have a decimal point in them, right? So we really have to understand what's happening here with this shift in order to know what to do with that. And I think that if I show you with whole numbers, that's a helpful start. So that's why I'm bringing this up here. So moving the decimal to the blank is equivalent to multiplying by 10. You might be thinking to yourself, or if not, I want you to be thinking to yourself, well, where's the decimal? Like when you multiply by 10, 100, 1,000, where is the decimal in this 32? Well, when you don't see the decimal, it means it's right after it. So 32, technically, I could write like this. I could write 32 point, and usually you just wouldn't see that, right? You'd see a 0 there. But technically, when you don't see it, it's at the end. We just don't write it like that because it looks weird. We wouldn't just put a decimal point because we're not separating anything if I don't have anything in the tens place. So you could say 32 times 10. We know that it's 320, right? Well, in order to get 320, wouldn't you have to move this decimal, because 32.0 is the same as 32, one place to the right to get 320? The answer is yes. Now, when you have 85 times 100, technically the decimal point's right there, right? If I'm going to multiply by 100, that's like multiplying by 10 twice, right? And you notice here there's 2 zeros. That's because my decimal point actually shifted 2 places to the right and moved to the end. Now right here, if I'm shifting these digits 2 places this way, that means that this 8 needs to be in the thousands place and this needs to be in the hundreds place. That means I need a digit in my tens place and a digit in my ones place. So we get 8,500. So multiplying by 100, same thing as multiplying by 10 twice. We shifted that decimal 2 places to the right. And when you multiply by 1,000, that's like 3 tens, right? So when you have 27, there's really a decimal point there. If I multiply by 1,000, that's the same thing as multiplying by 10 1, 2, 3 times. So now my decimal's there. If I want this 2 to be shifted 3 places over in the 10,000s place, that means that I'm going to need to have a 0 in my hundreds, a 0 in my tens, a 0 in my ones to be able to make that happen. So really, we're not just adding zeros, and we never were just adding zeros, right? We talked about the patterns beforehand. What we're doing is we're shifting the decimal to the right every time we multiply by 10. So when you multiply by 110, that means one shift of the decimal point to the right. Our digits are actually shifting to the left because as you go farther left with your place value, those digits increase. And multiplying by 10 increases the value, right? Okay, so let's try this. I have 6.8 times 10, and we said that moving the decimal to the right is equivalent to multiplying by 10. So do you see how the decimal point is right here between the 6 and the 8? When you multiply by 10, that means I'm going to shift this decimal, because this is just 110, one place to the right. So now what would be after the 68? And remember, we wouldn't just write 68 with a decimal point after it, right? That would just look funny. If you wanted to write 68.0, you could, but 68 is just fine. That's what happened. 6.8, all these digits want to shift over to the left. That means I need to shift my decimal point to the right, because when you move it to the right, instead of 8/10, now it's 8 ones. And instead of 6 ones, now it's 6 10s. All right, that's what's happening. For letter B, when you multiply by 100, that's like multiplying by 10 twice, right? That means that wherever my decimal point is at, I need to shift it 2 places to the right, because every one shift to the right is equivalent to multiplying by 10. When you multiply by 100, 10 times 10 is 100. So, or you can look at it, 2 zeros, that means 2 10s, right? So I would shift this one 2 places. Now it's after the 6, so I would have 496. For letter C, I want to multiply this value by 1,000. That's 1, 2, 3 10s. That means I want to take this decimal from where it's at and move it 1, 2, 3 places over. So now it's between the 9 and the 4, right? So if you look at this, I would have 329.4 as my answer. I dropped that 0 in front in case you're wondering why. Like when you look at this, don't I have 329? With the number 329, would you ever see a 0 in front of it? No. So when you shifted that over, that 0 was no longer necessary. We now have 329 and 4 tenths. Okay, now instead of saying 10, 100, 1,000, I'm going to use exponents, because I know that you're going to see it both ways and I want you to be fully prepared. So when you have 10 and 48 hundredths times 10 to the first power, this 1 means you're multiplying by 110. That means 1 shift to the right. So this decimal would move between the 4 and the 8. So everything else stays the same. It's just my decimal point that's moving. For 45 and 5 tenths times 10 squared, this means I have 2 10s. That means I need to move it 2 places. And this one's a little bit trickier. It's totally not impossible, so don't worry about it. But it's a little trickier because there aren't really 2 numbers to move it. Like in all the rest of them, there was a number, right? So when I notice that, I'm just going to write this down here so it's just a little bit easier for you to see. If I'm supposed to move the decimal 2 places to the right, that means I want all these digits to be able to shift 2 places to the left, because that's what's happening. When you hop one time, I just moved that from 4 10s to 4 hundreds, right? So I'm supposed to do 2 hops. When I hop here, there's nothing there, right? So what number would represent nothing in the ones place? 0. So if you are trying to shift places and you don't have digits there, you're going to put zeros there because you do have 0 ones. You need a number in that place, and I don't have any ones, so 0 ones. So this would be, I can write down all my digits. 4550, I know the digits, the decimals at the end, so I don't need to write it. I should put in my comma though. And commas and decimals aren't the same thing, so just be careful. All right, and now I have 94 and 86 hundredths times 10 to the third power. This 3 means 3 10s. So if I'm multiplying by 3 10s, that means 3 shifts. So right now it's between the 4 and the 8, right? I need 3 movements to the right here. So I'm going to go, there's 1, there's 2, there's 3. So what do I put underneath here? If I have 0 ones, I put a 0 in the ones. Now you can go ahead and write all those digits. I know my decimal point's at the end now. So 9, 4, 8, 6, I'm gonna put my 0, and now I'm gonna go 1, 2, 3, and put in my comma. So 94,860. So just notice I'm not just putting zeros on the end, right? Because we're not multiplying a power of 10 by a whole number. When you multiply by a whole number, we have to put a 0 in that placeholder, right? Because there was nothing there and the decimal point was all the way at the end. When the decimal point's not at the end, you're going to see it in that problem. That's the actual thing you're shifting to the right. Okay, now you understand division and multiplication are opposites, right? So when you learn to divide by 10 or 100 or 1,000, you kind of saw that instead of adding zeros, they're going away, right? And we looked at this as Just write this, I'll write it up here. You don't have to write this part, just watch. If you have 560 divided by 10, I could write it like that, right? And we said that 560 was the same thing as 56 times 10 over 10. This is division, right? What happens when you divide a number by itself? It equals 1. So I'd be left with 10 divided by 10 is 1. 56 times 1. And when you multiply a number by 1, the multiplicative identity, right, that fun one to say, it doesn't change. So when you see that you are dividing by a multiple of 10 and there's a 0 in your dividend, you kind of look at it as, oh, so those just cancel out. They're gone. But really what's happening is you're creating 1, right? This is like 56 times 10. So this is like saying 10 divided by 10 is 1. So when you look at this first problem here, there's a 0 in my divisor and in my dividend. That's equivalent to doing 10 divided by 10. And then just work with what's left. We're left with 56 divided by 1, which is 56. And this next one, here's a 10, here's a 10. That would equal 1. Here's a 10, here's a 10. That would equal 1. I don't have any zeros left in my denominator, so I can't cancel any out in my numerator, right? I can't make a division problem of 10 divided by 10. So I'm left with 420 divided by 1, which is 420. You could also look at this as 42 divided by 1, and we know that that 0 doesn't go away, right? It's like multiplying it by 10. All right, and then this last one, there's a 10, 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 there's a 10. All that's left is 18 divided by 1, which is 18. Okay, so in all of these problems, we divided by a power of 10. And these strategies that we're dealing with, this works when we are multiplying and dividing by powers of 10. And powers of 10 are like 10, 100, 1,000, 10,000. It's a 1 with a whole bunch of zeros after it, right? Okay, so here it says moving the decimal to the blank is equivalent to dividing by 10. So now we're dividing by 10 instead of multiplying by 10. And take a look at what happens here. We started off with 560, right? So I'm going to write that off to the side. And where would the decimal be in 560? It would be all the way at the end, right? We just don't put it because that looks funny. If you have a whole number and you have nothing in the tens place, you don't really need that decimal point. But it's there, right? So when we divided by 10, we ended up with 56, right? In order to get 56, wouldn't I have to move this decimal point one place to the left? Yeah. So if I move the decimal point one place to the left, I would end up getting 56. Now in this next one, we had 42,000. My marker is pooping out on me. Get rid of that one. I wish I had another purple. Oh, I do. Okay, perfect. Wishes do come true. Hopefully it works. There, yeah, it does. So in 42,000, the decimal point's really at the end, right? We just don't see it because it looks funny. When I divided by 100, I ended up getting 420, right? So I'm going to go ahead and move my decimal point 2 places to the left to get 420. 1, 2. And remember, 100 is the same thing as how many tens? 2. So when this decimal point moves, you get the 420. Now, technically, I know we get 420.00, but are those necessary? Do those change the value? No, so we usually just drop them, and that's how we'd get the answer of 420. And in this last one here, we had 18,000, and we're dividing it by 1,000. That means that we're dividing it by 10 3 times, and we got an answer of 18, right? To get an answer of 18, if my decimal point's right here, wouldn't I have to shift it 3 places to the left? And again, I could write 18.000, but those zeros aren't necessary. I can just see 18. So what's happening here, and it makes total sense because multiplication and division are opposite, is when you divide by 10, it's equivalent to moving the decimal to the left. When you multiply by 10, we moved it to the right. When we divide by 10, we move it to the left. So we're going to do the same thing here, but it's with division instead. Division is opposite. We're going to get something lower when you divide by 10, right? So I have 8.5 divided by 10. When you divide by 10, so every time you divide by 10, that's equivalent to moving the decimal 1 place to the left. So here, this decimal will move 1 place left. So now it would be in front of the 8. I could write down 0.85, but a lot of times with these decimal points, if there's nothing in the ones place, you'll see it written like that. Okay, that's equivalent. This is fine. That's how you're normally going to see it. Okay, in this next one, I have 14 and 9/10 divided by 100. That's like dividing by 10 twice, because 100 is the same as 10 times 10. So if I move this decimal if I'm dividing by 100, I haven't had all of my coffee yet. That means I'm going to move 2 places to the left because this is division. I want a lower value. So 1, 2, it would be in the front. So really what's happening is I'm shifting all of these digits to the right. And in order to do that, I have to move my decimal point to the left, because now instead of having 1/10, I have 1/10. So you could write it like this. It's now in front of the 1, right? We could write it like that. Most of the time, if there's a decimal point and there's nothing in the ones place, you'll see a 0 there. When I divide by 1,000, that's like dividing by 10 3 times. So that means I need to shift this 3 places to the left to make my digits go right. So 1, 2, 3. It would now be in front of the 6. And yes, you could write that. And again, this decimal point moved. Don't put 2 decimal points there. We're moving it. It's not staying put and then we're rewriting it. And again, there's nothing in the ones place, but there's something in the tenths. Put a 0 there. Okay, now in this next set, I'm sorry, this got spaced over. Just pretend this is moved over. Instead of saying divided by 10, I am using exponents because I know that you need to be able to recognize that as well. So I want to make sure my examples match up with what you need. If I'm dividing by 10 to the first power, this means I have 1/10. So that means, because it's division, I would shift it 1 place to the left. So now it's between the 9 and the 3. I would write 9.36, 9 and 36 hundredths. Here, I have 2 10s, right? I'm dividing by 10 twice. That means 2 shifts. Now, notice there's 1 digit here to move it, right? So if you move it here, there's 1 shift, but aren't I supposed to shift it 1 more? So I need to move 1 more so that the decimal point's here. So right now, I want this 4 to be in the hundredths place, and in order for it to be in the hundredths place, I need a digit in the tenths place. So I don't have any tenths, so I would write 0 there. So when you go to shift it, if you have some empty, I call them hops, because we're basically hopping that decimal point. Empty hops get zeros as placeholders, because I need these digits to all shift to the place value, so I have to put something in the tenths place so that this can be hundredths instead of what it was before. So we would have, maybe you want to write it like this, but usually if there's a 0 in the tenths place, you won't see it like that. You'll see it like that. Okay? And then this last one here, I have 7.036, 7 36 thousandths divided by 10 to the third. This means 3 shifts to the left because we're dividing. We want to make these values lower when you're dividing by 1,000, right? 1,000 is equivalent to 10 to the third. So with this one, I would need to move my decimal point 3 places to the left. I see that I have 1 digit in one of my first hop, right? But now I still have to go 2 more hops so that it's there. That means I need this 7 to be in the thousandths place, which means I need to put a 0 in the tenths and a 0 in the hundredths. So I had to put 2 zeros there, and it has nothing to do with what this exponent is. I had to put 2 zeros here because I had to shift 3 places, and I had 2 places that had nothing there. So I would have 2 zeros in front of my 7 and finish writing off the rest. Okay, I'm hoping this makes sense to you. We'll be doing more practice in class, but thank you so much for watching. I'll see you soon.